Hi, we're going to continue to talk about object-oriented programming, specifically about class and instance in this video. We just saw that we want, for the same type of object, for cars, we want a consistent representation of what they look like. What that means is really we need a blueprint for these same type of objects. So, for example, in order to have a car, we have to have a blueprint for the car, right? So class, and literally class, is the way that in Python and actually in many other languages, C++ and Java included, to define a blueprint that for basically anything. Okay, so class is the way, is the ticket into object-oriented programming. So before we talk about our own class, in Python, we've actually used classes already. Many of Python's, actually not many, all of Python's built-in types, such as integer, string, etc., they are all classes. So to prove that to you, I'm gonna actually just gonna type int I, equal to, I'm just gonna say 10. I'm gonna print out the type. I think you've seen this before, right? The type of an integer. So if I just run that, the type of I is, previously I told you to just pay attention to the fact that it's an int, but int is a class in Python, okay? And then obviously if you just print out I itself, it's just the value of I, and in that case it's 10. Now, this is equivalent to building an int from the value 10, okay? There's no difference between these two. We typically don't do this because, 10 is just a 10. We don't have to explicitly say that it's an integer. Same thing for a string. So we can just say hello world. And then if we say print type of S, and print S is actually, so a string is really, its type, it's a class, str, string, okay? That's what we printed out here. So all of the types that we learned actually up to this point, they are all classes. And so unbeknownst to us, we are already doing object-oriented programming. All right, so before I go on any further, I think it's kind of fun for you to pause the video and actually also check out some of the other built-in types that Python has and make sure they are, as I said, all classes. So, create a float or a list or a tuple, print out its type and the value, just like what I did previously here. Okay, so give that a try. Okay, so moving on, how do we define our own type, right? Because we want to represent our own complex data, such as car. Well, let's start with the simplest possible one. And I'm just going to say class, and we're going to make a class that kind of represent a blueprint for a car. So I'm going to say car, colon, and I am for now not going to put any definition in it. So let's take a closer look at this. What are these two lines of 3 words? What it actually mean? All right, so to define a class, we start with the keyword class. So that tells the Python we're defining our own class. Kind of like, to define our own function, we start with def, def. That defines a function. This defines a class. And then the next thing is the name of the class we want. So we can basically put anything, any valid names here. by convention, which means this is what you really should do, okay, that is in upper camel case. So what that means is if you put a bunch of words together, then the first letter of each of the word is capitalized, right? Well, this is only one word, so we capitalize C. Now, if you have other things, say if you define a class that represents the day of the week, then you capitalize D, O, and W, right? For a mortgage calculator, then you capitalize M and C. So obviously you don't use space in the name, and we also don't use underscore as in the case of snake case style. So another thing to know is the Python built-in types, they do not follow this convention. So as you saw, int, string, they're all lowercase, very short words. But that's just the way the Python is. For the built-in types, they use lowercase and short words. Anyway, so the name of the class is followed by the colon, which we've seen many times in defining functions and conditionals and stuff. So it basically signifies the beginning of a block of code, and that block of code will define the class. And then after the colon, we have an indentation. Oops, it should be 4 spaces, but well, that's actually a problem with my pasting all of my code. Oops. Okay. All right. Yeah. Indented block of code that will define our class. We're not going to put for this particular example. We're not putting anything there. And as you remember, if you want to have empty of anything in Python, you can just say pass. So this is actually legal. This is a very tiny, this is probably the smallest class you can make in Python. One very, very important thing here, right? When we say just a class and then give it a definition, or we have is just the blueprint, we do not have a car yet, okay? So just like we define the Python built-in int. If it's just there, we don't have an integer yet. We have to explicitly create an integer, right? So here we have a definition for car. We have not created any actual car yet. All right. So how do we create actual card? Well, fairly straightforward. We can just say car and followed by parentheses, just almost like we are calling a function, right? But here we are creating a car. Now, if you just create a car like that, there isn't much you can do about it. So let's assign it to a name. Okay, and then we can actually let's print out the type actually. Why not, right? And we can print out the value and let's see what it gives us. Okay, so gives us two things. The first thing we should know is that the type of this name or a variable little car is the big car, right? It's a class now, and it's the name of the class is capital C car. Okay, now it has this main thing here. This is just kind of the module it's in. I mean, we're in the main or global scope. That's what that is. So don't worry too much about it. But the important thing to know is that it's a class, and the name of the class is capital C car. Okay. Here's another interesting thing. For the second line, we print out the actual car itself. Okay. Well, actually, before I jump there, let's actually look at this line. That's important. So I'm going to go back to my slides. Okay, so the first thing we know is that when we say the name of the class followed by parentheses, this instantiates an instance of the class car. Okay, and obviously we can only do this after it's defined, right? We cannot instantiate an instance of this class if the class is not defined. Now, I use the word instantiate. Instantiate literally means just create. Okay, we create an instance based off the blueprint for car. Okay, now I also like to use the word instance instead of object because object is too generic for me. But it's okay. They are an instance of a class or an object of a class. They mean the same thing. I will more often than not use instance instead of object, but I will use objects when it sounds more correct. Okay. Anyway, instance object mean the same thing. Okay. So this car parentheses instantiate an instance of the class, and again, yes, remember to use parentheses. Don't just say car all by itself, even though that is valid syntax. But that's definitely most of the time not what you want. And then we assign this instance to the name, to the variable car. Okay, and then we can use this variable car as usual. Right? Just continue on, like I said. So the type is the class car. Another thing to note is that when we just print out car all by itself, it says it's a car, capital car, the class car object. Okay, so that basically, yeah, object instance. So this is no longer just a car class. It's actually an object of the car class. So this is an actual car. Okay, so far so good. We have a blueprint and we actually have an object based on that blueprint. Now, this blueprint is not very useful because it's got nothing, right? Like we said, what makes a car is all its attributes, actually, right? So these we can add more data to the instance we just created by using this particular syntax here. So I'm going to try to do that. So we start with the instance, and then if we want to say, specify the make for that instance, then we can say car.make equal to Honda car dot whatever model equals Accord, and etc. Car dot year equal to whatever 1998. That's, by the way, was my first car. Anyway, so that's that. You can keep on adding more attributes, right? So what they are is we are creating a bunch of what's called instance attributes. Now they're called instance attributes because these attributes, they are unique to each instance, right? So for example, a car.make can be Honda for this one car, but the car.make, the make of another car, can be a different brand, right? Can be Ford, can be Tesla, can be whatever. So these are called instance attributes. Okay, so the syntax here is we start with the instance, we call our instance car. We follow with the period the dotted notation. So we've seen that previously mostly in string dot format, but now more formally what this thing does is that the dot um, dereferences the instance. Okay, that's kind of the technical term. It basically just means the dot and then whatever the attribute follows the dot, this attribute is part of this instance. That's all that is. And then the name of the instance. Sorry, the name of the attributes. So okay, I forgot to put it here. Now these names, they are just kind of like variables, so they will follow the style of variables, which means they're going to be snake case. Name of okay, let me actually gonna just put it here. It should be name in snake case just because they're just like variables. Okay, and now I call them in attributes, or they're technically instance attributes, but usually just say attributes. They're sometimes also called data members or fields in other languages, but they all mean the same thing. Okay, now one thing to note, very important, that because the attribute is on the left-hand side of an assignment operator, okay, the attribute is created if it doesn't already exist in the instance, or changed if it already exists in the instance. So that works pretty much the same way like a variable, right? If you put a variable on the left-hand side of an assignment operator, we either create that variable if it did not already exist, or change the value of that variable. Okay, so attributes, pretty much like a variable, except it's part of an instance of a class. And then finally, on the other side, on the right-hand side of the assignment operator, is the value for the attribute. Right. So now that we created a bunch of attributes for our instance of car, we can read them back. Right. So if we can just say print cars make is that, model is that, and year is that, and then we say well, I'm going to put here dot format car dot make, right? We want to print out its make, car dot model, and car dot year. All right, so this is reading whatever value is already stored with the name, with the attribute. Okay, so if I run this, there, cars make is Honda, model, oops, spell, and year is that. So so that's that. Now obviously if you change this to Tesla, maybe the Model 3 and the newest one, so if you change those values, then these values that you read back is also updated as well. And actually, I'm gonna try to show another thing different, but you shouldn't be surprised with this. Is if I started with those values, and if I change them to something else, I print them again, then whatever I print the second time should be the updated values, right? That's different from the first. Okay. So much talk, and I think it's time for you to maybe try to define a class, or actually maybe modify the class that I already have. So you can add an attribute, say price, to the car instance and assign it to the value. I think that's roughly the price that I paid for my first car, but anyway, that was a long time ago. So you can try to make sure that works. Print it back out, right? And also create another instance of the class car and call it maybe car2 or something, and then create the same attributes and maybe give it different values so it represents a different car. Okay, so go ahead and give this a try. Assuming you've done that, maybe another exercise is actually try to create a new class. We're going to try to create a class called point, right? Which is another thing that, another quote unquote complex thing that we talked about at the beginning. This class would represent a point on a 2D plane. So you can create several instances of it. And then for each of the instance, you create an attribute, X and Y. Well, two attributes, X and Y for each instance. And then again, print them out. Okay, so go ahead and do that.